See if it's starting. Right. Let's see. Wait for it to start. Waiting for it to start. Wow, it's a little bit behind. There we go. All right. Wait for it to start. Wait. All right, so that's probably 10-15 seconds. So the next thing is, okay, so there's one edge, there's the other, there's extra space down here, and I guess I could move it this way, whoops, move it this way a little bit. Is it covering everything? Tell you what, let me get my glasses. Okay, so let's do it that way. Is it covering? I think it's covering everything. Now the funny thing is this crazy thing is gonna be, you're gonna have to correct me if I start moving it. If I start moving it off here, let me know. I'll put the keyboard over here. All right. I wish this drawer, this thing would lock somehow, but it's just kind of, I got a spot to kind of rest my shoulder on. Okay. So, okay, I think I just get rid of that. I think that's about where I was. Well, actually, did I work any of those problems? I don't think I did. So let me just grab one or two. Okay, this has 2 units on it. That has 1. Let's just start with that one. So what we'll do is we'll not just do what he's saying, we'll do a little extra there. Okay. Okay. All right, let me try that again. All right, there we go. So just grab that. Okay. Move over into here. You know what, before I do this, this is do a copy, paste, and paste. Let's see. Is it there? There? Okay, there we go. So now, I just sort of dropped that thing. Oh, wrong thing. Oh no. Did I lose it? I lost it from the thing because I hit the wrong button. Grab it again. So this is a simple, but I'm going to do more than what he tells us to do. So he says, express the vector RBA. Let's see. Look under that size. That's probably okay. Is a Cartesian vector. What I want to do in addition, here, let's see. Rotate this goofy thing. What I want to do in addition is I want to find the normal, unit normal from A to B. Then what I want to do is find the angles, alpha, beta, and gamma. And I want to kind of look at those. Okay, so there's a couple ways you can do this. The simplest way, I think all my pins are kind of large. Uh-oh. No. I guess that one's okay. Wait. Uh-oh, it's not changing color. So we're just going to stay in this color for a while. So we draw a vector here, and then draw a vector here. So I'll call this one RB. Call this one obviously RA. So if I want to look at RA, which is this one down here, I'll erase it because I can get two things a little bit better. So what I do, and this is one way you could think of it, To get to that point, I go here, and then I go there. So I had to go 3 out the I, and I had to run backwards 2 along the J, and then nothing along the Z. I didn't have to go up or down. Now over here, I do have to. So I'm going to follow the same pattern, and that is, and then the J, and then the K, or the X, Y, and Z first. So first thing I'm going to do, there's part of that X that's missing. I'm going to run a vector here, then I'm going to run a vector here, and then I'm going to run a vector here. So the first vector I run backwards 3, minus 3. I run in the positive direction 4, and then I run up 3. So now that you got that, if you just turn around and look at this thing, you say, okay, that's supposed to be a straight line. So this is RB, this is RA, and so if you look at the thing and you say RA plus this vector, the one we're interested in, which he's done it, it's drawn from A to B, is equal to RB. That's just a vector equation. So all you do is RAB. So I'm doing this a little extra, just all of the details in between. So if I just line up RB and subtract it from the other 3 plus 2J plus 0K, and then I'll add them, because that's essentially what this equation on this side says. Then I'll get RA to B equaling to this and this. I think it's still 6. Oh, it reconnected. It dropped out and reconnected. That's the network here. So he just wanted to find this vector. But I'm going to go further. Okay, so that's why it's not working out as integers, because he wants us to stop there. Now the next step, I want to find a unit normal along AB. So what I want to do, let me get all this junk off here. I'm going to try it again. Oh, it does work this time. Okay. So what I want to do is I want to find a vector that's a unit vector, goes from A to B. And obviously this is going to be longer than 1, because the reason I say that is every single digit here is greater than 1. So it's going to be larger than 1. So if I roll across here, and am I sliding off the screen, or am I still on the screen? Let's see. All right. So, okay. So I'm going to put this in as a vector there, and it's a 6. Okay. So I'm just going to list it as R, because I just don't want to list all the other stuff. So as a vector, it's minus 6, and it's a 6, and it's a 3. Now, for those of you in Matlab, you can do this. Oh, should I do the, here. Yeah, I'll do the word of the day. Okay. I should be able to log in, because it remembered me from the last. Oh, you're kidding. Maybe it's going to do it. All right, this is spring. This is statics. It's still, I don't know why it's popping up to that. My other courses don't do that. I don't know. So my email. So even if you're here, you can do this. This gets you extra points. How about rats? That's a good term for a day. So there you go. All right. Go back where I was. I was in here. Okay, so those of you here in Matlab, who have been in Matlab, who you're going to have to take the course eventually anyway. For those of you who haven't, this is, here, I'll just go ahead and do a second where I do this. I think I may have done this. I use this. And the reason being is because if you look at it, it's, okay. That's the last thing is what is a big deal. Drop-in compatibility with many Matlab scripts. So when you take your class here, it's 3003 is what it's called. That's all they do is Matlab. But you may not want to buy the Matlab license. You might, you know, why pay that if you don't want to? And so you just download this, and everything in that course you can do in this software. So you just download it and then run it, and everything is there. So in that context, you know, you can see him entering a column vector. Now, it turns out what I'm about to do, I'll show you. So this is a row vector. Turns out, if I would have gone back, here I'll do this first. Let's say, what's the norm of the R? Or essentially, what's the length of the R? Well, it's 9. So now if I go back and I list R to be in a column vector, you do that with these semicolons. Oops. And then it lists it vertically. And guess what? The norm is still 9. So, let's see, let's get back over here. So the length of this thing, RAB, is nothing more than 9. It's always 9. I mean, well, it isn't always 9. It is 9 if those are the values. So what you want to do is you want to divide this by 9, or the length of the vector. And so you get minus 6i over 9 plus 6 over 9 j plus 3 over 9 k. Now, in Matlab, or Octave, maybe I'll start calling it Octave because that's what it is. In Octave, the unit normal would be just listed as R divided by the norm of R. They give you that minus 2/3, and then 1/3. But that's what you got. So you get minus 2/3 I plus, what was that? Anyway, 2/3 J, 1/3 K. Now, just out of curiosity, if you wanted to look at the norm of U, it should give you back 1 because that's what you started with. That's what you wanted it to do. But the beauty is, if you look back in the text, you'll find out that this unit vector, any unit vector, can be written as cosine alpha I plus cosine, beta j plus cosine gamma k. So if you want this angle, you take the arc cosine of that thing right below it. I'm sorry, above it. So, interestingly enough, since I had it listed last in a vertical component, if I go back now and I take arc cosine, I want it in degrees, so I put the D, and then I type in the U, I get 131.8. Okay, I'm going to bounce back and forth because it's going to force me to. 131.8, 48.19, or is that 49? No, okay, 70.529. Now, does that make sense? And I'm always about that. So here's what I'm going to do. I'm going to do something really strange here. I'm going to do is I'm going to do this. I'm going to do this. Go ahead and get rid of that. And I'm going to do this. And then I'm going to draw this vector. Just not the whole thing, just right there. And then what I'm going to do is take this and put it right here. Now, I'm going to take this whole mess and I'm going to do an X on it to get it out of there, and I'm going to drop it down here where I can look at it, and then put it close to this, and then I'm going to recognize that, okay, so now the other thing I'm going to do is I'm going to go in here. I guess it really doesn't matter which one I do. I'm going to do one of these two. So this one's closest. So what I'm going to do is I'm going to represent, I'm going to use this to represent that graphically. So here's what I mean. I'm going to go backwards a distance of 2/3. Taking that, running it in the negative axis. I'm going to run this in the positive axis. Okay, that doesn't look exactly, but this distance is 2/3, and this distance is 1/3. So here, let me move this 2/3 over here. This is 2/3, and the reason I'm doing that is so I can complete that. So it makes sense that if you looked down this plane, that this vector right here sits behind that plane. So therefore the angle, the first angle, or the angle that was associated with this one would be alpha, and I almost wrote it that way, but here. That ends up being 131, which is greater than 90, means that this vector lays behind this YZ plane. Now, take the second one and you're taking this line and an angle between this line, this axis here, and this vector. So this is the U vector. And it's 48, it says. And that makes sense. It seems like it's a little closer down there, especially when you compare this with the 70. This one is 70 degrees. Slightly larger than this one, but not as big as that 130. 131. So let's head off and do one more, but this one we'll do with 2. Okay, 2 vectors, I mean. So here's 2 vectors sitting here. Okay, so the picture itself is fine. I don't know that I really need the words up here. It just wants to find the resultant force. So here, let me see if I can grab it. Then we'll have to put it on its own page. Grab its own page and just put it somewhere up there. Here. Yeah. Oops. I guess I just didn't touch it correctly. Okay. So first thing, okay, so first he has a FC and an FB. But he tells you the directions. I mean, of course, FC runs down towards C, and it's bolted to the ground here. And then, of course, FB heads down the pole or the rope to B. So what I need to do is I need to establish some vectors here. So I'm going to do the simplest first. I'm going to do RA. That is about as simple as you can go. 0I plus 0J. Plus it heads up 6K. Now I'm going to head a vector from the origin. Now he's placed an origin. He's placed the origin right there for us. So I don't have to think twice about it. He's measured everything from there. So what I'm going to do what I was doing before. I'll do RC. How do I get to point C from the origin? I'm going to start by heading out the I axis first, and it looks like I do 2I. Then I go to here, plus 3J, and I don't go up or down out of this plane. And so that's it. How do I get to B? I head out the x-axis this far, R3. Then I head back here to, ooh, that looks funny. And I don't move up or down. So I've got that. Now that I got those, they're written kind of big. So I'm going to make them small. And the ink size, I thought the ink size would change, but it doesn't. But they're still readable. So first, I want to do this one. I don't have to do that one first. So this is R to B. This is R to A. And the key here is I'm going to find this vector. The reason I'm pointing it in this direction directly is associated with the fact that the force is going that way. I can do this and find the vector that way, but that's the opposite direction of the force, and that's kind of a waste of time. So we want to go in the direction of the force. So I want to find the vector that goes from A to B. And so I could just do the vector addition. Go out RA, then go out RAB. And it's the same point as if I went just down B. So if I want to know RAB, just take RB, subtract RA from it. That's it. So instead of listing them this time, I'm just going to look up here at them, if that's okay with you guys. So what I'll do is I'll take, and so I can hack and write this stuff because I can use the control, whatever it is. I can control X will remove the writing. So I'm going to take I'm going to first start with the I component of RB minus RA. That just becomes 3. Then I'm going to do the J component. I'm going to take RB minus RA. That just becomes 2. Then I do the K component. RB, okay. Okay, I do RB minus RA. This is a time in which I do get a minus 6. Since I'm here doing this mess, I'm going to go ahead and do AC. Looks the same, RC minus RA. Now, let's go back and look at it. Here's the vectors. This one's going here. This one's going here. So I add RA, and then the vector again, what I'm doing is I'm making it go in the direction of the force here. So this will be RA to C in the direction of the force. And so I go out RA and then RAC. So in other words, RA plus RAC is going to get me the same as RC. So I'll just take that, move to the other side, and get this equation. So the similar mindset that we did here, we're doing here. And since I'm here, I'm going to go ahead and do that. Okay. So, I, J, and K. By the way, I know that's minus 6. So I'll start with C this time. 2 minus 0, 2. This time 3 minus 0. Now, here's something interesting. This goes along the lines of just the way he is in making this book. Here we go. Let's go ahead. I don't want it to be full screen. I'll go about right there. And then I think if I put the mouse over this, oh shoot, well, anyway. That's okay, I'll move it down. So I'm going to list these as vectors, and I'm going to go ahead and do the whole thing here. Just do a clear the screen, and then I'm going to say RAB is equal to a vector that's 3. I'm going to list them not in a column, but in a row because it takes up less screen space. 2, and then minus 6, and bam, there it is. So I'm here, so I might as well do RAC, and it is 2 and 3 and minus 6. Uh-oh, I did something wrong there. I really should go back. I mean, it's going to be okay, but I need to go back and just be precise there. What it was doing is it's waiting for the other bracket before it did something. Just so you know, this here I'll show you. So if I did this, I mean, it just puts them together. Or I could do this. This is stuff you'll learn in Matlab. Puts them together, but you don't even have to do them that way. You can do them like this without the inner bracket. It does it like that too. So anyway, let me go back to a point. That's the value. Now I'm going to find the norm of RAC. Wait, was it RAC? Yeah, well, RAC, RAB. 7. Guess what? Same value. 7 for both. That's because this length and that length are the same. So the length of these are 7. So now what do I do? Well, what you do now is I want to find the unit vector along AB. It's nothing more than RAB, the vector, divided by its own length, which we just found out was 7, but we're going to list it in its, well, I mean, I can go ahead and list it out. It'll be 3 over 7I plus 2 over 7J minus 6 over 7K. Now, if you want to see it in Matlab, what you do, the unit normal, AB is equal to RAB divided by, that's not divided by, divided by the norm of RAB. And if you look at, like, for example, 3 divided by 7, you'll see this number is the same as that number. And you can go through them and show that. And then it's not too surprising that here, UAC is going to be equal to the vector AC divided by its own length, which happens to be 7 as well. It's 2 over 7I plus 3 over 7J and minus 6 over 7K. That's because I just take that vector, copy it right here, divide it all by 7. I did the same thing here. I took this one, copied it right here, but I divided it by 7 and gave me a unit vector. Now, did I do that in Matlab? I did not. So UAC is equal to RAC divided by the norm of RAC. Gives you something. Now what you notice is this changed with that, and this one changed with that. This one remained the same. That's what you end up with. So now what did you do? Why are we doing that? Well, the reason we're doing that is we're going to find the vector that's a unit normal here, and a unit normal here, I'm going to take this unit normal vector and multiply times the scalar value of 840. That gives me the vector FB. I'm going to take the unit normal here. I'm going to multiply it times the scalar value of 420, and that'll give me the vector value there. Now, this is one of the things he does. Okay, so watch this. This is just to show you that this many years he's been writing this book, or this book has been out so long, that let's just look at FB, for example. I'm looking at the FB. So the FB is 840. The unit normal is UAB. So 840, shrink it back down, 840 times UAB. So again, the vector component comes from here. The length of it's 840. So I'll just take it, I'll say 840 times, I'll just copy this and stick it right here, 3/7 I plus 2/7 J minus 6/7 K. And watch this. This is, okay, so which one was it? UAB. So 840 times UAB. Is it UAB? Yeah. 360, so they count to be integers. 360, 240. And that doesn't always happen by the pole up here for that rope. In other words, you got this rope pulling it this way. You also have this one. Together, they're pulling the pole over this direction. So maybe that's a tree and somebody's cutting it and they want it to fall this way. They don't want it to fall that way. So they tie it and you cut it and it just sits there. Somebody comes up, pushes it. It's either going to fall this way. It'll have an arc that it'll land in. This rope won't let it land anywhere out there. This will keep it there, so if you look at it, it's going to fall like that. But let's take a look at that. Let's take a look at the other one, which was called FC. And it'll be 420. Stop moving. 420 times UAC. Is that correct? Yeah, it's the one pointing here to C. To make sure I don't mess up, flip the B and the C. Okay, so it's equal to, of course, 420. And what I do is I grab the UAC and I copy it right here. And that's 2/7 I plus 3/7 J minus 6/7 K. And not too surprising. I mean, I could do it. But, okay, 420. Did I list that thing or did I? I did not. Okay, so I want to list it as a character like FB. Okay, so I store it as a variable somewhere. So now I have it as FB is equal to that. Now I want to do FC is equal to 420 times UAC. Now, not too surprising, I got a bunch of integers here as well. And it makes sense. I'll show you why in a second. So FC will equal to, and I've already forgot, but it is 120I plus 180J minus 360K. It turns out that if you take 840, this number, and divide by 7, here, let's just see, 840 divided by 7, you get an integer of 120. So that's what's happening here. And then if you take 420 divided by 7, you get something that's an integer there, 420 divided by 7, and that's a 60. And that's what he's planning on doing. So the key is, if he can get his ropes to be an integer value, and then make the forces such that the force divided by the length becomes an integer, then he can get integers out of this. So this is not normal. This is very planned and very straightforward, and that kind of shows that he's been doing this book for a long time, and that's okay. So now, we went through this whole process. So what did we do so far? We found the links. From the links, we found the unit normals. Then we multiplied the unit normal times the force value, and we got force vector. So now what do? We just find the resultant force. FB plus FC equal to. Now, I can just look up here and do it. I can take the 120 and add the 360. And I can take the 180 and add to the 240. And then I can take the 360 and add to the 720. And they're both minus signs. Or I can go to Matlab or Octave, which is what this is. And I can say FC plus, did I hit a plus? Yeah, FB. I think I hit a caps lock there. FB. There we go. So 480, okay, yeah, 480, 420. So it becomes 480 I plus 420 J minus 1080 K. And that's it. Now, what else can we do that he didn't say we should do? One of the things we could do is we could say, hey, so this is the force, right? So what is the equivalent force? If I took this picture, did a copy, went down here, and said, I can't do it. Well, maybe I can. I can sort of do it. So here's what I'm going to do. I can use this white pen and say, I'm going to get rid of, this is kind of weird, and get rid of that force, and get rid of that force, and say, okay, I actually have an equivalent force that's kind of out here, and it's connected to somewhere. Okay, so what's the direction? And just out of curiosity, where does it land in that plane? This is something that's a little bit interesting. I never thought about that before. So I'll have the equivalent force comes this way. And somewhere, this line will cross through the plane, this X, Y plane. Where would it cross through? Where would I put another bolt? I got A, B, and C. Where would I put another bolt? Get rid of those two ropes and have the same thing. Well, first of all, let's find the value of the resultant is equal to the square root of all those squared. 480 squared plus 420 squared, 1080 squared. Now, again, okay, I did not label this, but now I'm going to call it FR for the resultant. And now what I'm going to do is take the norm of the resultant, is FR. How much force is there? Okay, now we're not into integers anymore because we're starting to go past what he's asking for. 1254.3. So the magnitude is 1254.3. That's the actual force that's being pulled. Now, what is the U in the resultant? It's nothing more than the FR divided by the the length of FR. So if I do this, now this time, I don't think I'm going to get any integers at all. Anything that's going to be comfortable. So the U resultant is the force resultant divided by the norm of or length of the force resultant. Okay, this is going to be a little strange. So, okay, I'm going to bounce back and forth. 382.382. 0.69i plus 0.33486j minus 0.866, no, 6106. Who was that beeping? Oh, it's still going there. Okay. So that's the direction that thing is going. Now, I'm going to try something different. Let's make sure I'm still. Uh-oh. Oh, I'm still there. All right. So I'm going to do something really weird. Okay, let's think about this. If I'm going... Okay. If I'm going to basically draw a vector, I want the other end of this vector. Okay, let's think about this. This will take a little thought. So if I multiply this vector times, so I have a unit vector here. You know what? I'm going to make this pen a little thinner. It's annoying me. So this is a unit vector here. UR. So if I multiply that times 2, it's twice as long. So the key is I will want to multiply that times some sort of constant, and then I want to add this vector to it. Okay, so if I say, okay, this thing is 6 foot tall, so I'm saying I have my vector RA plus some coefficient, some constant, times the unit vector in R, and I'm going to add those two together, and I'm going to get the vector that's out here that's going to D. Now, what happens is, let's think about this for a minute. So I will get a component I plus another component J and plus another component K. So I'll get a number here and a number here, right? But what I want is I want to find the bolt point on the ground. On the ground means Z is equal to 0. So guess what I want? I want that to be 0. So I want to input C as such a number so that that is forced to be 0. So, go away. Okay, so let's write this down. Well, believe it or not, RA is just simply the most simple. Did I even write it down? Yeah, here it is. Just simply that. So it is simply, oh, go away. What happened here? Okay, so it's simply 6K plus some coefficient constant times this goofy number, 38269I plus a constant times that number, 0.33486J minus the same constant times that number, 86106. So all I have to do is make this offset, oh, that's a K, offset that one. Does that make sense? In other words, I want to know the pin location. So I want this vector, I want to go up 6, I want to go down the force, I want to go all the way to the point where I'm finding the location where this is 0 is equal to 0, and that'll be the vector that's comes out there. And then we'll figure out, I hope this is not too complicated. So I want 0 to equal to 6 minus C1 times 0.86106. So it turns out C1, just a random constant, but it'll become apparent in a minute. Okay, so move the 6 over and divide it by 0.86106. 69, the constant 69 6.9682. Now here's what's funny. If I take that same constant and multiply it times this, and multiply it times that, that tells me where this point is. Hopefully I'm making sense. Often I make sense to myself, but so what is that? Okay, so 6.9682 times, well, I'll tell you what, we'll just multiply that constant times this use of R, and we'll see what we're talking about. Okay, so we'll call this a constant C1. C1 is equal to. Now I'll take C1 times UR, and notice what I get right here. I get minus 6. But the other is 2.666I and 2.333J, and that's the location that that pin should be in to hold that. Oh, and we're like less than a minute away. Hey, hang on, let's see. If I touch that, it'll count down the number of seconds. So I'm going to go ahead and call it quits. I did a little extra there, but that's okay. I hope that last part wasn't confusing, and I'm done.